Now, forget about the Kraken and monsters from the deep. I know, it's hard, but try. And you can forget about the Bermuda Triangle and other marine anomalies. They are nothing compared to rogue waves. Giant walls of water that suddenly appear and just as suddenly disappear on the sea surface. The destructive power of this phenomenon remained a mystery to humankind for a long time, but it appears that scientists have solved this secret. A rogue wave is a wave that exceeds at least twice all the surrounding waves. If you imagine the world ocean like a video game, then ordinary waves are your opponents. But the rogue one is a super boss. For centuries, hundreds and thousands of ships have gone missing during their voyages. People have made up a lot of legends about what was the cause of marine disasters. Sea monsters, underwater anomalies, mermaids? But today, scientists are increasingly inclined to believe that rogue waves are the main cause of unusual shipwrecks and missing ships. Some believe sailors' stories about anomaly waves, while others didn't. But no one could prove their existence. However, everything changed in 1995. When a giant wall of water 85 feet high collapsed on an oil production platform off the coast of Norway. The waves around this monster were 39 feet high. In other words, the monster wave was about the size of a 9-story building, and the neighboring ones measured about 4 floors high. The oil platform wasn't destroyed, but the wave showed it could cause considerable damage to any buildings. Immediately after that, people began to study the phenomenon of rogue waves. However, in the beginning, instead of answers, scientists got even more questions. So, what's so mysterious about this phenomenon? We know how ordinary waves work. What's the problem with finding out the nature of rogue ones? Well, in fact, the difference between them is huge. Ordinary coastal waves are very predictable. They form because of the wind and the uneven landscape of the seabed. Depending on the depth, terrain, distance to the shore, and wind strength, the size and speed of the wave increase. These waves are safe. If they're not big, you can surf. If they are big, then you'll see them in advance and run out of the water, like me. Rogue ones, unfortunately, are almost unpredictable. They can appear suddenly, even during a calm sea. They appear not only on the coastline, but also in the open ocean, like a high-water cliff. The conditions for the appearance of these monsters are very chaotic. When several waves combine their energy into one, it creates a rogue wave. But this process cannot be predetermined or predicted. How is this energy formed? How is it released? And how much of this energy is needed? The questions are too complicated. Now, to try to figure it out, you can place a special buoy with sensors that scan wave data in the water. Then, you need to wait for the rogue wave to appear. And you don't know if it's going to happen or not. Fortunately, it happened off the coast of Vancouver Island. This monster, which was named the Ukulele wave, was 3 times the size of the surrounding waves and had a height of 58 feet. Proportionately, it was one of the most gigantic rogue waves ever recorded. And do you think that buoy with sensors helped to determine the nature of rogue waves? Of course not. It just showed the wave's data. In order to solve the mystery, a group of scientists from the University of Melbourne went to Antarctica, and this time they managed to find something. They brought the most modern equipment for studying weather conditions in water. They installed powerful stereo cameras on the icebreaker SA Augustus II and obtained 3-dimensional images of the ocean surface. Now, observation showed that the formation of rogue waves began when small waves were most susceptible to wind. That is, waves of varied sizes and directions meet the wind, which makes several small waves combine with one large one. It grows faster using this received energy. This is not just a combination of waves, but also their physical effect on one another. Scientists call this nonlinear effects. To get closer to the solution, the scientists also used the fourth-order Stokes theory, which speaks about more complex interactions of waves and their energy accumulation. The theory didn't help much, but it made the whole study more strange. Scientists realized that small waves fed off one another. Then some waves became bigger than the rest and took away all the energy. This process is called modulation instability, and it explains why rogue waves appear so suddenly, as if out of nowhere. Still, scientists admit that even this information isn't enough for them to fully explain these giant waves. Now, long story short, oops, too late, the wind pushes younger waves together, causing them to grow higher and increasing their speed. One wave steals the energy from the rest, and boom, a giant rogue wave appears, looking disproportionately huge compared to the others. It hits a boat, an oil rig, or the surface of the ocean and spills out all that energy. And that's it, silence again. The existence of such a phenomenon has convinced scientists that rogue waves are the cause of many shipwrecks at sea. Now, seriously, think for yourself. When a ship gets into a storm, the captain reports it by radio and makes records in the logbook. But when a ship suddenly disappears from radar without any warnings about harsh weather, then it might have met a giant rogue wave. They're not tied to any particular location. They are sudden and unpredictable, and this makes them some of the greatest dangers in the ocean. So, what do we do now? How can ships, beaches, and oil production stations be protected? How to predict the appearance of a wave? Well, the answer is crest-trough correlation. It sounds incredibly difficult, but it's actually simple. The highest part of the wave is the crest. The lowest part of the wave is the trough. The idea is to measure how closely the ridges relate to the troughs. With strong correlation, waves form in dense groups. There are several regular waves and one or two large ones in the center. These conditions are ideal for the appearance of a rogue wave. Now, it seems obvious that scientists should use some instruments to measure the troughs and crests on the waves. It seems quite complicated, but in fact, these crest-to-trough correlations can be studied by watching the weather and currents. Scientists hope that they'll be able to predict the appearance of rogue waves using the same systems they need to predict the weather. So, you can take a breath. It seems we're safe. Or not. Given how the weather of our planet is changing, scientists expect an increase in wave height in the North Pacific Ocean. This will contribute to the appearance of giant rogue waves, even bigger than the ones people observed off the coast of Norway. How much bigger? 1.5 times? 2 and 3 times? Well, you better sit down. Scientists conducted experimental studies and found out that these waves can get 4 times larger than previously thought. Could the 85-foot-high wave recorded in 1995 be 4 times taller? It's hard to believe, but let's just imagine it theoretically. A rogue wave with a height of 340 feet may appear in the middle of a storm. This is more than the height of the Statue of Liberty from the pedestal to the tip of the torch. Such a giant wave can pull any ship underwater in a second and easily destroy an oil station. It can throw the Kraken or Megalodon out of the ocean like a stuffed toy. But how is it different from a tsunami? Well, a tsunami is born during seismic activity at the seabed. Such a wave grows, gains speed, and then crashes onto the shore. It's predictable, and you can spot it from afar. So, let's hope that scientists will be able to predict the appearance of rogue waves in advance and warn ships not to sail into the risk zone. Ordinary people who live in coastal towns and relax on the beach are also at risk. In the future, they'll have to look not only at the weather forecast, but also at the risk of giant waves. Ocean waves can grow much bigger than we ever thought and be far more dangerous than we realized. People used to believe that waves only moved in 2 dimensions, just up and down, like when you draw them on paper. However, a recent study shows that waves are 3-dimensional structures, able to move in different directions. This finding indicates that the ocean is more complex than we imagined, and today's ships, wind farms, oil rigs, and other structures near the coast might not be ready for what is coming. First things first, waves break. It might seem obvious, but the truth is that we don't fully understand how and why that happens and don't know all the steps involved. What we do know is that when waves break, they change shape and become steeper. To better understand this process, researchers initially assumed that waves were two-dimensional. This assumption was necessary because it made it easier to study waves, whether in theory or through computer simulations and experiments. But here's the thing. Saying that waves are two-dimensional doesn't really capture what ocean waves are like. When most people think about waves, they imagine typical, non-threatening waves you see at the beach. But the ones we're talking about here happen in open water and form when waves coming from all different directions meet up. This wild meeting occurs under certain conditions at the ocean, like in a spot where two seas meet, or when winds suddenly change direction, like during a hurricane. When waves from two different directions come together, it creates this three-dimensional wave. To test how these unique waves behave and how they could make the ocean more dangerous for us, two researchers built a special tank, like a giant swimming pool, measuring 82 feet wide and 6.5 feet deep. All around this tank, they installed 168 mechanical paddles. These paddles act like giant hands, pushing the water back and forth to create waves, just like you would if you moved your hand through water in a bathtub. Stop the video and go do that right now. No, wait, I'm kidding. Anyways, the paddles can generate waves of varied sizes and shapes. Plus, they absorb incoming waves so that they don't bounce around the pool and mess up the tests. Beneath the tank, they put 28 huge fans that push water across the tank to simulate ocean currents, mimicking how ocean water moves. Altogether, they circulate around 2,400,000 liters of water in the tank. All of this was done to create a kind of mini-ocean, controlled by some really cool technology. Great! Everything was set, and it was time to test. The experiment has shown us that three-dimensional waves can become twice as steep as two-dimensional waves before breaking. Let me explain. So, the normal waves you see on the beach break when they reach a very steep angle. They have a limit, a maximum steepness, if you will. When that limit is crossed, the wave breaks. So, what this study is telling us is that waves in the open ocean can get as much as 80% steeper than this limit before they start breaking. That also means they can get almost twice as high as normal waves before they start to break. But the researchers found something else that was interesting. Normally, when a wave breaks, it creates a white cap, that foamy part you see on top, and once it breaks, it's done. There's no going back. It's lost its energy. But when these multi-dimensional waves break, there is no white cap. They can only keep growing. That happens because the wave's energy isn't just concentrated in one direction, allowing waves to continue growing even after reaching the steepness limit when they're supposed to break. It's like these three-dimensional waves can redistribute energy and continue building up in the middle of the ocean. That means that together, these waves can grow 4 times steeper and larger than what we previously thought was possible. So, we are talking about bigger, massive waves that can suddenly appear in the middle of the ocean. It sounds scary to say the least. That's why, for our own safety, it's important to understand how this phenomenon occurs. Maybe buildings and homes along the beach aren't at such high risk from this. But these giant waves can pose a bigger threat to things that are in the middle of the sea, like oil rigs, wind farms, and boats. This finding raises significant questions about whether these constructions, as we design them today, are safe and could handle such extreme wave patterns. The thing is, sailors have been trying to warn us about this for centuries. In the 19th century, a French explorer named Jules Dumont d'Urville, I gave it a shot. He reported seeing rogue waves over 100 feet high during his voyages. Even though he was very experienced and respected, plus 3 other people confirmed that it had indeed happened, his story was discredited. Like this account, all other stories about massive and wild waves in the middle of the ocean were dismissed as myths, just tales sailors told to make their adventures sound more exciting. Hey, don't we all? Scientists only started taking these reports seriously in 1995, when a rogue wave was finally measured for the first time. The terrifying event happened at a gas platform in the North Sea, about 100 miles off the coast of Norway. The structure was built to withstand a wave of 64 feet, and even then, they thought a wave that big would only happen once every 10,000 years. But they definitely weren't ready for what happened on New Year's Day, when a monstrous 85-foot wave, 21 feet taller than predicted, hit the platform. In a more recent case from 2018, 8 men were on a 61-foot fishing vessel over 400 miles northeast of Hawaii's Big Island when they suddenly got hit by a pair of rogue waves. One hit the back of the boat and the other slammed into the side. It was too much to handle. A lot of water came over the top, flooding the boat and pulling it down to the depths. The crew had to abandon the ship and get into a lifeboat immediately. Thankfully, they were all rescued with no injuries at all. These are just a few examples showing that our current oil platforms and ships might not be prepared for massive rogue waves. That's why experts suggest that one solution could be for ship designers to make ships strong enough to withstand double the significant wave height. However, they'd probably need some convincing because of the increased costs. So, here is a pretty convincing fact. It's believed that between 2011 and 2018, 210 waves of this type were recorded around the world, but it's very likely that the real number is much higher. What triggers rogue waves is still somewhat of a mystery, but we know they are not caused by movement on the seabed. Instead, they seem to be more related to bad weather. In Tampa Bay, for example, most rogue waves come in from the west, especially when it's stormy or windy. But we can't say this is the main cause everywhere in the world, as experts believe there could be several other factors at play. What is really concerning is that rogue waves can strike without warning. The open sea can be completely calm when suddenly the whole scene turns into a fight for survival. So, can we actually predict this phenomenon? It looks like we can. In a very recent study, researchers created a computer system that uses measurements from buoys to predict unusually large waves 5 minutes before they happen. It can catch about 3 out of 4 rogue waves. While the system does have some false alarms, the researchers say that from a safety standpoint, knowing a rogue wave might happen is better than not knowing. And I think we can all agree on that. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reached the shores of Phang Nga and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific, and 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Euclid wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Pun intentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happen not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. The sea is kind of rough today. Nothing special, but still, you have that sinking feeling in your stomach. Call it a sense of foreboding. Something bad is going to happen, and then you hear terrified shouts. You turn around and see a giant wave, much higher than the one surrounding it. Is it a tsunami? That's true. When people think of frightening, destructive waves, tsunamis are the first thing to come to mind. But the one that is going to crash against your ship has a different nature. It's a rogue wave. Both tsunamis and rogue waves can lead to catastrophic consequences, but the difference lies in what causes these walls of water and where the destruction they bring about occurs. So, imagine a giant 60-foot tall wave rolling over your ship. It's a miracle that the vessel doesn't sink. This massive wave, a rogue wave, seems to have appeared out of the blue, very suddenly and unexpectedly. But however mysterious, solitary, and ominous rogue waves may seem, they're actually not that rare. Now, imagine the average room in your house. The ceiling there is likely 8 feet high. A typical 2-story house is somewhere between 20 and 30 feet high. And the Statue of Liberty is 111 feet tall if we measure it from the toes to the top of the head. Now you have something to compare rogue waves with. The largest of such waves can reach a height of 50 to 90 feet. To be considered rogue, a wave must appear seemingly out of nowhere and be higher than other waves in the area. But how much higher is still under debate. Some experts think it should be at least twice as high as other large waves in the area, while others disagree. Rogue waves are also steeper than regular waves, which normally take the form of massive swells. This allows ships to maneuver up and down such waves, even when they're really high. A rogue wave, however, looks like a wall of water, and since it's steeper than other waves, it slams into a ship with enormous force, sometimes breaking over the vessel. Another reason why rogue waves are a mystery is that no one has ever filmed the formation of such a wave and followed its life cycle. There are several photos of rogue waves, but for many centuries, the only evidence of their existence was legends and stories told by sailors who survived them. Scientists are still not sure how rogue waves form, but one theory involves wave reinforcement. It happens when two waves interact and their heights get combined. So when a 15-foot wave passes over a 30-foot one, let's do the math. It results in a short-living 45-foot wave. But rogue waves can occur not only in the ocean. On November 10, 1975, on Lake Superior, a group of 3 rogue waves, also known as the Three Sisters, might have sunk the SS Edmund Fitzgerald, an American Great Lakes freighter. The ship and the crew members were lost in the catastrophe. The waves followed each other too closely, so the ship couldn't recover and shed the water from the first wave before the following one struck. The captain of a ship that was not far from the Fitzgerald reported that his vessel had been hit by 2 30 to 35-foot waves. These waves, likely followed by a third one, then moved further in the direction of the Fitzgerald and might have caused the sinking. Now, let's wave bye-bye to that, and let's move on to tsunamis. It is an extremely dangerous natural disaster. It's very different from rogue waves. In most cases, a tsunami is caused by an underwater earthquake. Usually, when a tsunami is born, it's just a few feet high. But the closer it gets to the shore, the larger it grows. Soon it enters shallow waters and starts to slow down. The first tsunami wave crashes against the shore. Its top moves faster than the bottom, and that's what makes the wave so high and steep. The lowest point of the wave gets to dry land first. In the process, it creates a vacuum effect that pulls the water away from the coast, burying the harbor and seafloor. Those who recognize this first sign of an approaching tsunami still have a chance to save their lives. 5 minutes later, an enormous wall of water hits the shore and wipes out everything in its way. But it's not just a single wave, there are many. This phenomenon is called a wave train. How fast this train is traveling depends not on how far it is from the source of the waves, but on the ocean depth. Tsunamis can move as fast as a jet plane in the middle of the ocean, but once they enter shallow waters, their speed drops. The first tsunami wave isn't usually the strongest, but lots of people don't know it and make the grave mistake that sometimes costs them their lives. After the first wave is gone, they relax and believe the danger is over. That's why the next waves, much bigger and more powerful, catch them off guard. Now sometimes a tsunami comes as a torrent of foaming water. At other times, it makes the sea withdraw, leaving behind stranded fish and overturned boats. Also, if you spot a slight rise in sea level, it might be the sign of an approaching tsunami. The incoming water is the first tsunami wave. The second one can be even larger, and it comes sometime later. You can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. Repeated wave surges can also warn you about a tsunami. If you see unusual swells coming at regular intervals, it might be time to evacuate to high ground. Surprisingly, some of the largest tsunami waves in the world were caused by landslides. For example, a landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. Its height was 1,720 feet. The mega tsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. When a third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean, it triggered a tsunami the size of one of the tallest buildings in the world, Shanghai Tower. The wave was around 2,000 feet high. Another bizarre and dangerous ocean phenomenon is square waves. They appear when two different wave patterns crash into each other at 90 degrees. It often happens near peninsulas or land where two different seas or oceans meet. This phenomenon does kind of look spectacular, but only if you're watching it from the shore. Don't even think about getting in the water to play with such waves. Cross currents in that spot can easily pull even a skilled swimmer under the water. Square waves have caused many shipping accidents over the years, too. And if you see wild, choppy waves carrying ocean debris and seaweed, stay out of the water too. It can be a sign of a strong rip current. That can carry you far away into the ocean. And now, let me tell you about a much larger, I would even say planet-wide phenomenon called Rossby waves. There are two kinds of such waves, oceanic and atmospheric. But since we're talking about ocean waves, yeah. Slow-moving Rossby waves are totally different from ocean surface waves. They don't look like those waves that break along the shore. No, Rossby waves are giant movements of the ocean stretching horizontally across the planet. They can span hundreds of miles in a western direction and are so massive they can change the climate conditions of our planet. They contribute to high tides and even flooding in some areas all over the world. The movement of Rossby waves are complicated and depend on the location. For example, in the Pacific, waves that are closer to the equator take from a few months to a year to travel across the ocean. At the same time, waves further away from the equator often need more than 10 years to make this journey. So, as it goes by, be sure to wave. Welcome to the Spirit of Discovery cruise ship, which will take you on an unforgettable sea voyage around the Canary Islands. The azure endless ocean, delicious food, the highest service, premium cabins, and a terrible nightmare that you will probably remember for the rest of your life. This is exactly how one luxury trip of the Saga Cruises Company ended last year. Instead of relaxing during the cruise, passengers felt fear and horror, and even had health problems. And that's why. On October 24th, the Spirit of Discovery liner started a 2-week cruise around the Canary Islands. There were about 1,500 people on board. About 1,000 were passengers, and the rest were crew members. The first week went great, but then the liner encountered a serious problem called nature. There were strong winds and big waves. The captain decided to return to the UK ahead of time, but the decision was made too late. The ship was caught in a severe storm in the Bay of Biscay. A powerful wind with a force of 11 points hit the vessel. To make it easier for you to understand, the 11-point wind is able to tear out trees together with roots, destroy residential buildings, and plunge entire cities into chaos. Such a storm is rare, but Spirit of Discovery was unlucky enough to get into its epicenter. 11 points is the penultimate place on the Beaufort scale, which determines the wind rating. The most powerful storm has 12 points, and this is a hurricane. The wind reached a speed of 65 miles per hour, which is about the same as the average speed of a car on a highway. Not only did it push the Spirit of Discovery, but it also raised huge waves 25 feet high. Just imagine a wall of water the height of a 3-story building collapsing on a lone ocean liner. At that moment, the captain sent a message to all the passengers through the cabin speakers so that no one left their place. And his voice sounded worried enough. All the passengers had to lie down and hold on tight. According to the witnesses' words, the ship remained caught in the storm for about 15 hours. They held on with all their might so as not to crash into the walls and floor. All this time, tables were flying around the ship, dishes were breaking, furniture was moving all over the cabins. The waves smashed windows, partitions, and doors. Some people were knocked down because they couldn't hold on for so long. The storm hurled the passengers from ceiling to floor, from wall to wall. The ship's crew turned the dining room into a medical area to provide assistance to those who had been hurt. Despite the difficult and terrible conditions, the ship's team did a great job. They regularly informed passengers about the current situation and tried to calm everyone down. There was no panic and chaos on board. When the storm finally ended, the ship continued its journey and finally reached land, where medics urgently evacuated 8 passengers to the hospital. One of them was never able to survive this storm. It's good the ship didn't meet a rogue wave during the storm. This is a natural phenomenon that can appear during a storm and even in still water. It's a giant wave with a height of 60 feet. Like a 6-story house, it collapses onto a ship with incredible speed and capsizes it. And then the wave suddenly disappears. This is no joke. A similar wave has been recorded in the Gulf Stream off of Charleston, South Carolina. It's scary to get in its way. Now, let's go back to the past to remember one of the most terrible maritime tragedies. No, we're not talking about the Titanic. We'll talk about the Greek liner Laconia, which set sail from the English port of Southampton on December 19, 1963, with more than 600 people on board. However, just 3 days later, a terrible tragedy happened to the ship in the boundless waters of the Atlantic. At 11 p.m., in the barbershop hall, an electrical malfunction occurred. The problem led to a fire, which quickly spread to other rooms. The crew couldn't cope with it, since the fire was spreading too fast. The ship's team turned on the fire alarm, but there was no command to leave the vessel. Only 2 hours later, the captain ordered the passengers to evacuate. All this time, people were either relaxing in their cabins or enjoying a party in the ballroom. The crew was probably trying to put out the fire without causing panic. However, when the situation became critical, the evacuation began. People panicked and ran to the lifeboats, but many didn't manage to get inside. One of them was John Morris. He survived this catastrophe and shared his memories of how he put his family in a lifeboat while he stayed on board the ship. He didn't even have a life jacket. Since there was nowhere to go, the ship's crew opened a bar so that people could relax a little. However, at that moment, boilers began to explode inside the ship, and it became clear the vessel wouldn't stay afloat for too long. John Morris decided to jump into the water right in his tuxedo. As soon as he was overboard, he grabbed onto a piece of wooden deck cargo and swam as far away from the ship as he could. The giant liner could sink at any moment, and when such a huge object goes down to the seabed, it forms a water funnel that pulls along everything around. Rescuers arrived at the scene sometime later. Fortunately, John Morris's pregnant wife and young son were alive, but his mother-in-law unfortunately didn't survive the disaster, like many other people that day. Of course, after this incident, the Greek Ministry of Merchant Marine initiated a thorough investigation. For 2 years, they collected information from passengers and the captain, studied the technical characteristics of the ship, and eventually came to certain conclusions. According to them, the ship's crew gave the evacuation order too late. Not all passengers were able to get into lifeboats, but half of those boats remained on board because of the chaos that prevailed during the evacuation. Several officers of the liner were accused of negligence, but the captain and his first mate received the most criticism. As for John Morris, he stated that he felt himself under protection that day. Another unusual story happened on a cruise ship relatively recently. Spoiler alert, the ship didn't sink, there was no evacuation, and the weather was good. However, for many passengers, this journey became a real challenge. Imagine that you've been working for a long time and saving up money to go on your dream trip on the Celebrity Mercury cruise ship in the Caribbean. You arrive in South Carolina, from where the ship begins its journey. You get on board, looking forward to a week's rest. At first, everything is fine. People are having fun, chefs are cooking delicious dishes, and beautiful daytime landscapes turn into night parties. But then suddenly, many passengers start throwing up. Someone is in a hurry to go to the toilet, and someone stays and vomits right in the halls. The cruise turns into chaos. More and more people feel terrible because of unknown poisoning. You also visited the restaurant and eaten seafood, but fortunately, the disease has avoided you, which can't be said for more than 400 other passengers. Almost every 1 in 4 people on board face gastrointestinal problems. There were almost 2,000 people, and a quarter of them are in bad condition. Crew members do endless cleaning. They wash the deck, give people nausea pills, and ask them not to leave the cabin till the illness passes. The captain sends several samples ashore to determine what caused the poisoning. Unfortunately, the cruise is already ruined, and all the passengers have unpleasant memories. So the company organizing the trip issues certificates that can be used on future cruises. It's not the most pleasant experience, but it's still better than nothing. Now, imagine if, instead of just feeling sick, people got infected with some kind of bacterium that would turn them into zombies. It would be much more exciting and scary. Now, do you think you could survive on such a ship full of zombies? And how would you do that? Tell me about it in the comments. On December 5, 1952, a nauseating yellow-gray fog engulfed London, claiming 12,000 lives. This wasn't mere mist. It stank of rotting eggs and stretched 30 miles wide. Buses halted, planes were grounded, and ambulances were trapped. For 5 days, the city vanished in the stench and sludge. Streets slick with a black ooze. Those who dared ventured out stumbled blindly, smudging their faces while birds crashed into buildings. With visibility zero, thieves ran rampant, and even indoor shows were canceled. The Great Smoke sent over 100,000 people to hospitals, leaving a grim legacy of demise and decay. The causes of this tragedy started long into the past. Something called pea soup fog became one of the symbols of London in the 19th century. Nature wasn't to blame for this fog. It was caused by people burning coal to heat their homes and run factories. In fact, London's air started getting smoky all the way back in the 13th century, when people began widely using coal. It got worse as the city grew bigger. By the 17th century, people were already complaining about the dirty air. King James I tried to prevent so much coal burning with new laws, but nothing really changed. As more factories popped up during the Industrial Revolution in the late 18th century, the problem blew out of proportion. The air was full of tiny particles that water clung to and formed dark, heavy clouds. This mix of smoke and fog became so bad, people called it smog. Yep, this word was invented in London in the early 20th century. The smog got so thick sometimes it could last for a whole week, and it made people ill. Some even passed away because of it. Even though the smog was harmful, people didn't want to stop using coal because it gave them jobs and kept their homes warm. So the problem lingered. By the 20th century, thick fogs were happening less frequently, finally, because factories started moving away from the city. But on that December day in 1952, an anticyclone appeared over London. This meant that the cold air near the ground got trapped under warmer air higher up, like a lid keeping everything underneath. Because of this, all the smoke from factories, cars, and home fireplaces couldn't float up and away like usual. Instead, it clung near the ground, mixed with water in the air, and produced an extremely thick, dirty fog. Plus, daylight in December is shorter, and it was really cold, so people had to use even more coal for heating and lighting than they normally did. All this led to a disaster. It was clear that sulfur particles from the burning coal made the fog yellow and smell like rotten eggs. But scientists couldn't figure out why and how these particles turned into sulfuric acid. Decades later, an international team of researchers recreated that scary fog in a lab. They used samples of air and atmospheric measurements from the fog in 2 large Chinese cities that have high levels of sulfur dioxide in the air, just like London during the Great Smoke. They learned that the thick, dirty air, called haze, doesn't form in the same way in London and in China. In London's fog, Smoke from burning coal released two gases, sulfur dioxide and nitrogen dioxide. These gases mixed with water droplets in the fog, which made it harmless at first because the water diluted the harmful chemicals. But as the water evaporated and there was nothing to dilute the two dioxides, the fog became very acidic and hazardous to breathe, so it damaged people's lungs. In present-day China, things are a little different. A third chemical, ammonia, joins the mix. Now ammonia, which comes from farms and cars, helps balance out the acidity of the fog, so it's less harmful than London's deadly fog. But the scientists found that cutting down on nitrogen dioxide and ammonia could still help China reduce its air quality problems. They hope that their discovery will help both understand London's past fogs and give China ideas for making its air cleaner. It could also save the health of millions of people around the world who are now living in cities with bad air quality. After the terrible fog of 1952, everyone realized how serious London's air problem was. 4 years later, the British authorities created a law called the Clean Air Act to stop something like that from happening again. This law banned people from burning smoky fuels like coal in their homes or in factory furnaces in some parts of the city. To help people adjust, the authorities gave them money so that they could switch to cleaner heating options like oil, natural gas, or electricity. It took time for these changes to make a big difference, and sadly, another dangerous smog happened in 1962. But the Clean Air Act was a very important first step for protecting the environment and people's health. Almost a century before the Great Smoke, another smelly event happened to London, the Great Stink. Back then, people didn't have proper bathrooms or sewers, and all the waste from houses and factories went straight into the River Thames. When the weather got super hot in July and August, the water level in the river went down, and piles of waste, sometimes 6 feet, popped up on the muddy banks. The smell was so terrible that even Queen Victoria and Prince Albert had to cancel their relaxing boat ride on the river. The politicians working in the brand new Parliament buildings, which were right by the river, couldn't handle the smell either. The air inside was so terrible that they had to hold handkerchiefs over their noses to breathe. They even tried soaking the curtains in chloride of lime, hoping it would cover up the horrible odor. Many Londoners believe that the bad air, called miasma, caused horrible things like cholera, which had already taken the lives of lots of people. Engineer Joseph Bazalgette solved the problem as he built a new sewer system that would move all the waste away from the city. His sewer system was so well designed that it still works today, even though London has grown to over 8 million people. On the other side of the Atlantic, in the United States, there was also a day when you couldn't see your hand before your face, and it was impossible to breathe outside. But the reasons for this Black Sunday were very different from the Great Smoke of London. In 1931, it almost completely stopped raining in the southern Great Plains. This drought lasted for nearly 10 years. Without rain, the farms dried up and the soil turned to dust. Strong winds blew this dry dirt into the air and created huge dust storms. These storms, called black blizzards, made it hard to breathe and see anything. People tried to protect themselves by putting Vaseline in their noses, wearing masks, and sealing their homes, but the dust still made many of them sick. In 1934, things got even worse. It was the driest year in over 1,000 years. Temperatures went over 100 degrees for weeks, and the land became even drier. On April 14, 1935, after months of terrible weather, the sky finally looked clear, and there was barely any wind, which was rare for this area. People came outside as they were hoping that the worst was finally over. When Oklahoma minister announced that a few good rainstorms would make the land fertile again. But unfortunately, that morning, a cold wind from Canada met warm air in the Dakotas and started a massive dust storm. The storm grew to hundreds of miles wide and thousands of feet tall. A sunny day instantly became completely dark. Drivers had to hide in their cars, and other people went down into basements, found refuge in barns, fire stations, tornado shelters, and under their beds to stay safe. The storm didn't stop for hours and took at least 20 lives. Many people couldn't stop coughing, and one man went blind. The storm was so strong, it carried 300,000 tons of dirt across the country and even reached the East Coast.
Lake Michigan is one of the largest and most mysterious freshwater lakes in the United States. And now, deep inside it, scientists have stumbled upon something unexplainable. Vast, round craters scattered all across the lake's floor. It all started in 2022. A team of researchers wanted to map the lake's bottom and look for some shipwrecks. At first, they were sure it's going to be just some typical rocky terrain or sandy patches. But what they saw on their sonar screens stopped them cold. Strange, circular shapes that looked almost too perfect to be natural. They were hiding about 500 feet beneath the surface, in places where the water turns dark and impenetrable. Those guys are huge, ranging from 300 to 600 feet wide. They also plunge nearly 40 feet deep. And there are dozens of them, neatly arranged like some footprints. But the team had no idea what these things were. Then, in August 2024, the mystery only deepened. Using a remotely operated vehicle, they got a closer look at these formations. There were about 40 of them. No one had ever seen anything quite like this before in the Great Lakes. What could have created those craters? Could they be ancient? Perhaps remnants of some geological event lost to time? If that's the case, it's weird how long these holes have likely been sitting there, undisturbed. Theories started popping up. One possibility was that they could be sinkholes or dolines. Those are basically holes that suddenly appear in the ground when the surface layer collapses. The rock beneath the surface, often made of limestone, gets slowly dissolved by water over time, creating voids underground. When the surface of those voids can no longer hold its own weight, it caves in, and this forms a hole. Think of it like when you poke a straw through the lid of a drink. Sinkholes can be small dips or huge, spanning up to 2,000 feet. They can happen gradually or all at once. Sometimes they can swallow entire cars or even buildings. And Lake Michigan sits on limestone bedrock. It erodes pretty easily when water flows through it. Sinkholes like these have already been found in Lake Huron, and they look kinda similar. But there are some plot holes, no pun intended, with this theory. For example, it's wild how they all would be so huge. It's also weird and pretty rare for sinkholes to occur in a lake bed. They also kinda resemble a straight pattern. They seem to extend generally southward, forming a loose line, which is pretty weird. If these are sinkholes, then they're definitely not playing the usual geological rules. Though it might be some new, unusual process at play beneath the lake's surface that we haven't discovered yet. There's another theory though: glaciers. Glaciers are wild rivers of ice. They covered much of the Earth during the last ice age, and they're incredibly powerful. While they might move slowly, sometimes only a few inches per day, they have such immense weight that they can reshape entire landscapes over thousands of years. Glaciers can grind and scoop the land beneath them. They're basically like colossal bulldozers. Their weight, combined with the slow but steady movement, grounds down everything beneath them: rocks, soil, even bedrock. This can create deep gouges in the Earth's surface, called glacial troughs. During the last ice age, there were lots of glaciers all over the northern US, including the Great Lakes region. If they moved across what is now Lake Michigan, they could have carved out these deep holes. Glaciers often move in a pretty straight path. As they move, they cause terrain to erode, but the resulting erosion varies based on terrain. Sometimes there are places where the bedrock is softer or fractured, and these places are more easily carved and crushed by the glacier. That could explain why some holes could be bigger and deeper than others. Harder bedrock is less affected. But usually this leads to rounded, crescent-shaped depressions known as chatter marks. Those marks are more like grooves rather than circular, big craters like those in Lake Michigan. Once the glaciers melted, the Great Lakes themselves formed. If the craters were formed by them, they may have filled with water, becoming part of the Michigan Lake. Though this theory is more like a speculation, so we need more evidence. But there's another layer to this mystery. The craters are not just curious geological formations. They actually may hold valuable clues about early life on Earth. Parts of Lake Michigan, especially dark ones, are relatively low in oxygen. It's like a lighter version of deep ocean environments that often have very little of this element. For example, hydrothermal vents deep in the ocean, underwater openings in the Earth's crust with some hot, mineral-rich water that are often very low in oxygen. But some organisms love places like these. For example, opossum shrimp. Teeny tiny shrimp-like creatures that love cold, deep waters. They get their name because they have a pouch to carry their young until they're ready to be on their own, like an opossum. Or deep-water sculpin fish, small bottom-dwelling fish that also enjoys cold lakes. They're well adapted to living in dark waters and usually stay close to the lake bed. And weird organisms like invasive quagga mussels, which kinda look like shells. These are small freshwater mussels that have spread there to the Great Lakes. They attach themselves to hard surfaces and can cause problems for ecosystems by competing with native species for food and space. All these guys could be in Lake Michigan, and even more. There might be microbes or even bacteria that are specially adapted to these harsh conditions, just like it was in Lake Huron. There's only a handful of creatures that could survive deep within these craters, and studying them could give us insight into how life once flourished in Earth's ancient, oxygen-poor oceans. That's because it's in places similar to these, where some of the earliest life forms thrived. Early Earth had an atmosphere with little oxygen, although it was much more hot and ancient microbes adapted to this. The Great Lakes, especially Lake Michigan, have always had a bit of a ghostly reputation. Like even this mission was organized to study the shipwrecks. There were about 6,000 of them in the Great Lakes. Many of these wrecks are still sitting on the lake beds, preserved by the cold, fresh waters. And shipwrecks aren't the only strange things tied to the Great Lakes. Over the years, there have been stories of unexplained disappearances. Boats and even planes have vanished without a trace. The lakes, often calm on the surface, can suddenly turn dangerous with unpredictable storms and massive waves, leading to these mysterious events. Not even mentioning all the creepy stuff people notice there over the centuries, such as ghostly lights above water or bizarre weather patterns like eerie, sudden fogs that seem to appear out of nowhere. In 2007, they even discovered some prehistoric structure that looks like Stonehenge there. Well, it was way smaller, but still. It lay about 40 feet below the surface in the heart of Grand Traverse Bay, and it's speculated to be about 9,000 years old, way older than Stonehenge. Looks like this is a print of those who lived in the area thousands of years ago. These massive stones are arranged in a careful, winding pattern stretching over a mile. They range in size from basketballs to compact cars. But one, in particular, stands out. A boulder 3.5 to 4 feet tall, 5 feet wide. It's etched with the image of a mastodon, a creature that roamed the Earth about 11,000 years ago before it went extinct. It probably sank there during the end of the last ice age we mentioned. This period had reshaped the region. This place is underwater now, but back in the day, it was still dry land. So the stones were probably created by people who lived there, though we're not sure why. Were they used as hunting blinds? Or was it some sort of an ancient calendar? Who knows? Only about 15% of the Great Lakes floors have been explored. Now, scientists are gearing up for a deeper dive into this mystery, both literally and figuratively. They want to analyze the lake beds surrounding the craters, hoping that maybe something in the environment around them might have caused them to appear. They have initiatives like Lakebed 2030. These missions should map the entire underwater landscape. This would help us learn tons of interesting stuff about Lake Michigan and our planet's past. Who knows what other secrets these dark waters hide?
It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient cratons around the world. They mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that cratons might not be as indestructible as they thought. Some cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has three main parts: the Western Bloc, the Eastern Bloc, and the Trans-North China Orogen, a zone that lies between the two blocks. Scientists found that during the Mesozoic era, the Eastern Bloc lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure. And that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the Cretans, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists look closely at their chemical makeup, they realize the age of crystals matched the rocks found in Greenland, not Scandinavia. They use special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other. In November 2020, something terrifying happened in the ocean near British Columbia. Out of nowhere, a massive wave, as tall as a 4-story building, rose up and tossed a lonely little buoy way up in the air. Scientists later confirmed that it was the most extreme rogue wave ever recorded. Such a wave is so rare that experts think that something like that might only happen once every 1,300 years. Interestingly, if that buoy hadn't been floating there at just the right time, we might have never known this wave even happened. For a long time, people thought rogue waves were just sailor stories, something like scary tales passed around on ships. But in 1995, everything changed. On New Year's Day, a monstrosity of a wave 85 feet tall slammed into an oil platform off the coast of Norway. Scientists were shocked, since their models had never predicted a wave that big. That wave became known as the Doppler wave, and that was the first proof that rogue waves were real. Since then, scientists have spotted more of those giant waves, even in lakes. The one near a place called Ucluelet on Vancouver Island was special, not because it was the tallest, but because it was lots bigger than the waves around it. You see, to be called a rogue wave, a wave has to be more than twice as tall as the ones nearby. The Doppler wave was about twice the height of the other waves around it. But the Ucluelet wave? It was nearly 3 times taller than its neighbors. When scientists said this made it probably the most extreme rogue wave ever recorded. Now imagine a huge wall of water suddenly rising in the middle of a calm sea. That's the kind of ocean drama we're talking about. Very few rogue waves have ever been seen with human eyes, especially not ones that extreme. Scientists are still trying to understand how these monster waves form so that they can get better at predicting them before they strike. To do that, they track rogue waves in real time and run computer models to see how wind and water team up to create such powerful surges. Now, the giant wave off Ucluelet was picked up by a special buoy floating offshore. That buoy wasn't alone. It was part of a whole network placed out at sea by a research group called Marine Labs. Their goal is to learn more about the dangerous surprises the deep ocean can throw at us. Even when rogue waves happen far from land, they're still a serious threat. They can smash into ships, damage offshore wind farms, or wreck oil rigs. And if they come close enough to the coast, they can easily put people at the beach in danger, like it happened in April 2025 in Australia. Thankfully, the Ucluelet wave didn't hurt anyone, and neither did the famous Doppler wave before it. But other rogue waves haven't been so harmless. Back in the 1970s, some ships vanished without a trace. And now, scientists think freak waves might have been to blame. Bits of wreckage were sometimes found later. They were torn apart as if struck by a massive wall of water. Scientists think we could see more of these waves in the future, and this prediction is quite alarming. A 2020 study predicted that wave heights in the North Pacific might rise as the climate continues to change. That means the Ucluelet wave's record might not last as long as once expected. To make things even more intense, new research suggests these waves can be up to 4 times taller than scientists used to believe. And honestly, it sounds terrifying. Imagine sailing in the middle of the ocean and seeing a sky-high wall of water rising out of nowhere in front of your eyes. And rogue waves appear just like that, unexpectedly, unpredictably in the open ocean. While there's no exact size that makes a wave a rogue wave, they've been measured anywhere from 26 feet, like a 2-story house, to more than 80 feet tall. These waves are super steep, have sharp towering peaks, and can be strong enough to damage ships or oil rigs. But what causes them? That's where it gets tricky. There isn't just one thing that makes a rogue wave happen. They can form when different wave systems crash into each other. Think of it like a bunch of waves from different directions suddenly lining up just right, and boom! They combined into one huge wave that's way taller than usual. Other things can help too, like fast ocean currents, strong shifting winds, or certain underwater features like reefs or deep channels. Those can force waves into a small space, making them stack up. And still, when scientists know all these ingredients, rogue waves are still super rare and really hard to predict. Rogue waves aren't the same as tidal waves or tsunamis. Even though rogue waves can be just as dangerous, they occur for different reasons. Tidal waves happen because the moon and sun pull on Earth's water, making oceans rise and fall. Tsunamis happen when earthquakes, volcanoes, or big underwater landslides push giant waves across the ocean. Rogue waves, on the other hand, suddenly show up out of nowhere in the open sea. Big ships and oil rigs are built to handle waves up to about 50 feet tall. But rogue waves often get even bigger than that. That's why they can cause a lot of damage. For example, in December 2022, a huge rogue wave slammed into the cruise ship Viking Polaris near Antarctica. It broke windows, hurt some people, and sadly, even led to the loss of one life. Rogue waves have caused other accidents too. That's how dangerous they really are. These days, scientists know for sure that such waves happen way more often than you can imagine. I'm talking about one rogue wave for every 10,000 normal waves. Studies also show that waves have been getting bigger over the years. Still, rogue waves are tough to predict because we don't have enough information and they come up so fast. Now, even though rogue waves occur in the oceans all around the world, some places get more of them. One is near South Africa, where a strong current called the Agulhas flows. Another is the North Atlantic Ocean, where big currents like the Gulf Stream meet. Rogue waves have also been spotted in parts of the South Atlantic, Indian, and Pacific Oceans. But even if you live far away from those places, don't relax just yet. Rogue waves can happen in big lakes too. A famous example is the SS Edmund Fitzgerald, a giant iron ore freighter that sank in Lake Superior during a storm in 1975. The lives of all 29 crew members were lost, and a rogue wave might have caused the ship to sink. And that's not the only disaster caused by a rogue wave. Before scientists started measuring these waves, many shipwrecks had been mysteries. Now, some experts believe rogue waves caused some of them. For example, the USS Cyclops disappeared in 1918. The culprit could have been a rogue wave. Other ships, like the Norwegian tanker Wilstar in 1974 and the German freighter MS München in 1978, were hit by huge waves too. The Andrea Gale, a fishing boat lost in 1991, was probably sunk by a rogue wave too. Even modern cruise ships have been hit by giant waves. Rogue waves are, and were, quite popular among artists too. The famous Japanese artwork, Under the Wave off Kanagawa, shows a huge wave that many people think is a tsunami. But experts think it might actually be a rogue wave caused by wind. Rogue waves also appear in movies. For example, take the 2006 movie Poseidon. In it, a giant rogue wave hits a luxury cruise liner, which is making a transatlantic crossing. And as we see, it's something strange, unexpected, and way more mysterious than any other wave caused by the ground shaking. The surface of this river looks as if it's covered with fish scales. Is it a giant water dragon or some other ancient monster? Not really. The explanation is much more boring, but surprising at the same time. Now let's start from the very beginning. This is the Shantung River in China, and this is Hangzhou Bay, its estuary, which is the tidal mouth of a river, where the tide meets the stream itself. Now this area is home to the world's largest tidal bores. A tidal bore is a strong tide that pushes up the river against the current. In the Shantung River, such tidal bores can reach a whopping 29 feet. The area regularly sees trains of large waves moving upstream. But in 2021, during a scientific expedition, experts discovered a marvelous natural phenomenon unique to this area. Sometimes, the tide comes in swirling waves. That's the famous fish scale tide. Thing is, this region has rotating currents, which means that the tide doesn't just move inland and then simply reverses its direction. Instead, a rotating current easily changes direction without changing its speed. This makes the Shantung River perfect for winding up with groups of waves crashing into one another at oblique angles, which is like a cross sea. Let's speak about this phenomenon now. These four-sided wave patterns in the ocean look mesmerizing, as if the ocean deities decided to play a round of giant chess. But what you observe is the phenomenon known as square waves. They're often called cross-sea and grid waves too. The thing is, most waves reach the shore and break parallel to the coastline. But in some regions of the world, these waves create a chessboard-like pattern on the surface of the water. When you look at these waves from above, you might think there's an underwater grid forming square-shaped ripples. But square waves aren't caused by anything taking place beneath the surface of the water. They're the result of the way the water moves. Weather patterns in certain regions make waves form at different angles. When two opposing swells crash, we've got this unique pattern on our hands. However beautiful and unusual this natural phenomenon is, it's also extremely dangerous. If you spot square waves while swimming, get out of the water immediately. Square waves usually come hand in hand with rip currents, incredibly strong currents flowing seaward from the shore. Plus, square waves can reach 10 feet in height, and that's not something even an experienced swimmer can deal with. So, we're done with the seas for the moment and are moving to the largest active volcano in Europe. It's Etna, and it continues to amaze us with jaw-dropping smoke ring shows. But wait, people live there. Isn't it time to evacuate them? The volcano looks like it's about to go off. Well, let's calm down. There's no need to fuss. Experts assure us that the production of such rings doesn't mean that a big eruption is on the way. These white smoke rings are made of water vapor and are generated by bursts of gas bubbles inside a narrow duct over a magma chamber. Etna was even nicknamed the Lady of the Ring, and currently the volcano is breaking its own records. For example, in the year 2000, the volcano produced around 5,000 such smoke rings. According to researchers, no other volcano on Earth produces as many volcanic vortex rings as Etna. Southeast Crater is especially active. It emits countless beautiful vapor rings. Now, don't look away from the sky. You might witness something like what the residents of New Jersey saw recently. A massive fireball lit up the sky in the Garden State and surrounding areas. A meteor falling to the ground looked like a bright streak of light, and the folks of several New Jersey towns, as well as some parts of New York, Pennsylvania, and Connecticut, reported this show to the American Meteor Society. Security camera footage posted online by some witnesses of this awesome phenomenon show the flash dash across the sky within a couple of seconds at 3:43 a.m. Another unbelievable phenomenon captured recently is one of the rarest in the world and almost impossible to see with the unaided eye. A West Australian photographer was shooting a wet season thunderstorm just outside of Derby when he managed to film on camera a few red sprites. He said later that they were gone in the blink of an eye. He described red sprites as huge, feathery tendrils of purple and red and specks of bright red. Red sprites are massive electrical discharges that take different shapes and look like reddish-orange flashes. They last for just fractions of a second and occur after super-strong lightning strokes. Even though they're usually caused by the lightning discharges between a thundercloud and the ground, sprites soar up into the air, up to 60 miles. Interestingly, this phenomenon had been dismissed and considered to be fiction for decades, until scientists finally caught it on film. Since that time, red sprites have been recorded regularly. Catatumbo lightning is the world's longest lightning storm. The heart of the storm, which repeats every year, is over the mouth of the Catatumbo River, where it empties into Lake Maracaibo in Venezuela. This storm towers higher than a regular one. Catatumbo lightning occurs for 140 to 160 nights a year, lasts for 9 hours a day, and produces 16 to 40 lightning flashes per minute. Maybe you've heard of how they say lightning doesn't strike the same place twice? Well, Catatumbo doesn't seem to know about this rule. Or at least, it doesn't prevent storm clouds from gathering in the very same place year after year. A fellow hill walking in the UK has captured amazing shots of a weather phenomenon that was called an angel in the sky. So look at it. This scene was captured with a Canon 5D Mark IV camera. The silhouette, though, isn't some non-material thing. It's just the shadow of the photographer at the center of a circular rainbow. Mesmerized, the photographer took a few more photos and continued walking. Such an effect is produced when an observer stands above the upper surface of a cloud. It can also be a mountain or some other high ground, and the sun should be shining from behind their back. When the observer sees their shadow, the light is reflected in such a way that a bizarre circular glory appears around the point directly opposite the sun. Another cool sky phenomenon was witnessed in Auckland. Look at this. What does it remind you of? I bet you think it looks like a spaceship from a different civilization, but it's just a rare meteorological phenomenon. Everyone who saw the circular cloud formation said it looked like a hole in the cloud cover, and some also added that a small rainbow was visible inside. This phenomenon is known as a fall streak hole and a punch hole cloud. Such a formation is quite rare. Even experts have seen it just a few times throughout their careers. What happens here is some sort of atmospheric disturbance within supercooled water, the disturbance being an airplane or something similar. As a result, the supercooled water rapidly turns into ice crystals. Since the crystals are heavier than the surrounding cloud, they fall out, leaving a hole behind. The process happens high up in the atmosphere and is quick. It takes only minutes or so. Well, let's get back to the ground and examine the phenomenon people in the US can witness. It's an extremely rare one. Nothing similar has happened like this since 1803. What is it? Billions of cicadas from two different broods are merging together from the underground after more than 200 years. All these loud singing insects belong to two distinct families of periodical cicadas. One group emerges to the surface every 13 years, and the other every 17 years. It's a rare occurrence when the cycles of both groups align. This year, this once-in-a-lifetime event is taking place since two groups with different cycles are emerging at the same time. These broods are known as Brood 13 and Brood 19. They have been seen and heard across the southern U.S. and as far north as Illinois. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Dropner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of three large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard. Trace your finger around the very bottom of the African continent like this. Seems like a simple task, right? But in real life, out on the ocean, it's basically the nautical version of entering hard mode in a game. Except you can't rage quit. Every sailor who's ever faced it knew they were in for a storm buffet, unpredictable currents, and a constant sense that the ocean was out to get them. The legendary Cape of Good Hope has a misleadingly cheerful name and a way less cheerful reputation. The story starts back in 1488 with Portuguese explorer Bartholomew Dias. He was the first European to make it around the tip of Africa. When he saw the terrifying storms tossing his ships, he named it the Cape of Storms. But his king, John II of Portugal, decided to rebrand it to the sunnier Cape of Good Hope. Yeah, he wanted to promote it as an optimistic route for merchants and explorers. Plus, the discovery was a good omen that ships from Europe could reach India by sea. But the sailors who actually had to steer through it soon lost all the optimism the name promised. The Cape sits where the Atlantic Ocean and Indian Ocean meet, violently, and the winds there are brutal. They don't just blow in one direction, they flip around, like the world's worst fan setting. In the southern hemisphere winter, June to August, cold fronts from the Atlantic blast through with violent storms. Add some rain, fog, huge waves, or all of the above. If you were a sailor back then, your odds of survival felt closer to winning a chest of gold in some 16th century lottery than actually getting through in one piece. And then there are the currents. The cold Benguela current from the Atlantic slams into the warm Agulhas current from the Indian Ocean. Instead of blending nicely, like a smoothie, they churn up massive chaos and produce rogue waves that can rise higher than a 10-story building. Sailors describe them as walls of water that just show up to ruin your day. With modern equipment, you can survive if you meet them, or better, avoid them. But back in the 1500s, when your technology was a wooden ship and a prayer, one rogue wave could wipe out your entire voyage. And as if the Cape of Good Hope wasn't enough drama, a few miles east, there's the even nastier Cape Agulhas. This spot is the southernmost point of Africa, where the Atlantic and Indian Oceans officially meet. Cape Agulhas has shallow waters with reefs, hidden rocks, and sneaky sandbars that shift around. For centuries, sailors called it a ship graveyard. Historians have counted hundreds of wrecks here, including ships loaded with gold, porcelain, and spices that never reached Europe. The bones of ships still lie under those waves, like a giant warning sign saying, "Don't even try it." Now, if we zoom out to show the broader history, the stats are brutal. Between the 15th and 18th centuries, during the Age of Sail, so many ships sank here that European traders treated the Cape like a terrifying game of odds. You could make a fortune bringing back silk, spices, and jewels from Asia, or you could vanish into the ocean. That's why sailors passed down horror stories like campfire tales, ghost ships haunting the Cape, cursed waters, and there was also the famous legend of the Flying Dutchman, doomed to sail around the Cape forever. Navigating all this before GPS, satellites, or weather forecasts in a creaky wooden ship with no compass and some half-reliable maps was almost impossible. With no ports nearby to duck into for shelter, the sailors were all alone out there, sort of like playing hide-and-seek in a thunderstorm while blindfolded. Historians note that many of these brave folks regularly got blown off course or smashed into rocks they didn't even know existed. So, eventually, someone came up with a better idea. Let's dig a shortcut. In 1869, the Suez Canal opened in Egypt. It connected the Mediterranean to the Red Sea. Ships traveling between Europe and Asia didn't have to play the Cape's stormy lottery anymore. Using the canal reduced the voyage from the Arabian Sea to London by some 5,500 miles. Today, the canal handles 12 to 15% of global trade. That means millions of containers, tankers, and cargo ships take the safe shortcut instead of risking the so-called Cape of Storms. Now, there's another, less famous danger zone too, Cape Corrientes in Mozambique. Portuguese sailors dreaded it in the 1500s and called it a ship-eating monster. Its name literally means Cape of Currents, because the water there rushes with insane force, strong enough to throw ships off course and onto the shore. Historians estimate that up to 30% of Portuguese ships sailing the India route were lost there. So even before they reached the Cape of Good Hope, they could already be sinking. Now, let's not forget the economics. Sailing around Africa wasn't just risky, it was expensive. More days at sea meant more food, more water, and more exhausted crews. Losing ships to storms was costing millions of dollars in today's money. Insurance companies dreaded covering voyages around the Cape because the odds of having to pay out a claim were so bad. When the Suez Canal opened, it wasn't just about saving time, it was about cutting the cost of disasters. Even today, with modern radar, weather forecasts, and GPS, rounding the Cape isn't a walk in the park. Of course not, it's water. Anyways, cargo ships that try to avoid canal fees or blockages, like the infamous traffic jam in 2021, still face monster waves and storms. Technology can predict the weather, but it can't stop the ocean from throwing a tantrum. Every captain who rounds the Cape today still knows they're passing through one of the most dangerous maritime zones on Earth. Yet another zone most ship captains choose to avoid is the roaring 40s and furious 50s in the Southern Ocean. That's between 40 and 50 degrees south latitude. Unlike the Northern Hemisphere, where continents break the flow, down here there's nothing but ocean. It's an endless highway for storms with no speed limit. Sailors gave this zone its dramatic nickname because when you're here, the wind doesn't whisper, it screams. Scientists have confirmed that these roaring winds can hit speeds up to 125 miles per hour. And screaming winds mean screaming seas. Waves in the roaring 40s can reach heights that make skyscrapers jealous, smashing against ship hulls with the force of a battering ram. Historically, clipper ships braved these waters to shave time off their voyages between Europe and Asia, but they paid the price with torn sails, broken masts, and sometimes entire crews swallowed whole by the sea. Even today, modern vessels avoid the 40s unless they have no choice. There are safer paths, routes that might take longer but aren't this risky. The 40s and 50s sure sound scary, but wait until the ocean tightens its grip in the Drake Passage. This narrow strip of water between Cape Horn and Antarctica is the gladiator arena of the seas. The entire Pacific Ocean is trying to squeeze through a gap only 500 miles wide and collides head-on with the Atlantic. Add the southern ocean currents, among the strongest on Earth, and you've got a recipe for chaos. The Drake doesn't just throw waves at you. It throws walls of water up to 50 feet high. Ships here don't ride the ocean, they cling to survival, like toys tossed in a washing machine on the highest spin cycle. The reason it's so brutal is pure physics. With no landmasses in the Southern Ocean to slow down wind or current, the Antarctic circumpolar current races around the globe. When it slams through the narrow funnel of the Drake, it accelerates like a jet engine. Storms roll in uninvited, and icebergs drift lazily into shipping lanes, ready to take a ship down any moment. Even experienced sailors describe the Drake as unpredictable. It's calm one moment, chaos the next. Historians note that before the Panama Canal opened in 1914, every ship heading from the Atlantic to the Pacific had to pass through here, and countless ones never made it. Today, cruise liners and research ships still brave the passage to reach Antarctica, but with enough seasickness bags to remind passengers that they're not on a pleasure cruise. They're crossing one of the most dangerous ocean stretches on the planet. So look at this narrow passage between the north of Morocco and the southern part of the Spanish region. It's called the Strait of Gibraltar. There are only 8 miles between the two continents, but for some reason, there's no bridge, despite people having been dreaming for centuries about connecting these two regions. There are places in the world where a bridge over water stretches for a much greater distance. For example, the Lake Pontchartrain Causeway near New Orleans, Louisiana, goes for 24 miles, which is 3 times the length of the hypothetical bridge between Africa and Europe. That's listed in the Guinness Book of World Records as the longest continuous bridge passing over water. It consists of 2 parallel bridges and connects the urban area of New Orleans with small settlements in the north of Lake Pontchartrain. 9,000 concrete piles hold more than 1,000 decks above the water. This large-scale structure was built in the middle of the 20th century. It only took 14 months from the start of construction to its completion. American engineers created a unique technology for attaching concrete piles to the base of the bridge, and this bridge is still functioning. So, what's the problem with building a shorter bridge to connect Africa and Europe? Let's first find out the value of the 8-mile bridge that could connect two continents and the reason why everyone is talking about it. In fact, the value of such a bridge would be enormous. Diamonds, oil, minerals, Africa is full of valuable materials, and Europe is happy to buy these things. This theoretical bridge could allow people to transport things for trade quickly and comfortably. But now, the exchange of goods between Africa and Europe is only possible thanks to airplanes and cargo ships, and airplanes are extremely expensive because of hefty fuel price tags. In addition, air travel is often delayed because of bad weather. There are long customs procedures and transportation from the airport to the destination. Ships can also be a problem. The narrow area of the Mediterranean Sea, where the two continents are closest to each other, is a dangerous place because of storms and strong currents. The transportation of your diamonds is highly dependent on weather conditions. The second advantage of such a bridge would be the creation of tens of thousands of jobs. People from Europe and Africa would build hotels, ports, parks, and even small towns for each other. The coastal parts of both continents would become a new economic center. And just imagine how much investment those places would attract. Europe and Africa would be much closer than ever before. You could drive from a small Spanish town to a safari park in northern Morocco, buy Moroccan tea, get some argan oil, and go home for the evening. Or you could take a high-speed train across the beautiful Mediterranean Sea. People would open hundreds of restaurants, amusement parks, shopping malls, and a museum next to this bridge. But, unfortunately, it's impossible to build such a bridge, at least at the moment. And here's why. The main problem is the Strait of Gibraltar itself, because of its strong currents and seismic activity. How can you start large-scale construction if, in a couple of days, an underwater earthquake can trigger giant waves and take all the ships underwater? Even if you build a bridge, rapid streams of water that constantly change direction can shake the entire structure and tear the connecting parts of the construction. The bridge over the Strait of Gibraltar must have a strong, sturdy system that will withstand seismic activity. Huge resources are required to create such a complex structure. Despite the dangerous passage between the two continents, it remains one of the busiest points in the world. It's the only place on the planet connecting the Mediterranean Sea and the Atlantic Ocean. About 300 ships pass through this area every day. Not only merchant ships, but also fishing vessels and tourist boats. There are not so many places in the world where you can watch whales coming out of the water. Not only people, but also marine creatures often visit this passage because of the peculiarities of the sea currents. But we'll talk about that later. Another problem is the depth of the strait. In simple words, any bridge over the water is built on long metal piles. Builders and engineers stick piles into the seabed and use them as a holding base for the whole construction. But installing such piles firmly enough is a difficult task because of the uneven seabed. The seabed has a unique geological landscape, irregularities, and different densities of the Earth's rock. There are also reefs, rocks, and pits. Any seabed requires extensive geological studies before piles are installed. However, the bottom of the Strait of Gibraltar is especially difficult because of its depth, almost 3,000 feet. It's one of the deepest straits in the whole world. Just imagine, you'll need the height of 10 Statues of Liberty to reach the surface of the water from the bottom of the strait. What kind of pile should be used there to hold the entire bridge? Most likely, one pile will have to consist of several parts connected into one large metal rod. And don't forget about seismic activity. Let's say you've installed perfectly strong piles, but the next day an earthquake occurs and destroys the entire structure. And a strong current is carrying fortifications all over the Mediterranean Sea. The next problem is probably the most important one, because it concerns marine life. The Strait of Gibraltar has a high salt content. This natural element makes water heavier and makes it descend to the bottom of the deep Mediterranean basin. Then, this salt water pushes up cold water from the seabed into the Atlantic Ocean. These changes in water density, as well as fast currents, create sea vortices and turbulence. It's like a raging cauldron of cold water that raises a lot of nutrients to the surface. The hollows and hills of the Strait of Gibraltar are filled with different substances and sunlight, and this creates ideal conditions for the formation of phytoplankton. Whales, dolphins, and other marine creatures adore this delicacy. That's why you can see about 7 species of whales and dolphins in this place. What might happen to phytoplankton after the start of global construction? Carbon dioxide, crushed rock, tons of dust and ashes, falling building materials – all of this could significantly pollute the environment. Without phytoplankton, many fish would go extinct. Without fish, thousands of fishers wouldn't be able to get food and earn money. But even if the bridge was built, cars and trains would continue to pollute the air and water. This disruption of the delicate balance in this narrow strait can lead to larger-scale environmental disasters. Dolphins and whales may leave to look for food elsewhere, and thus take resources from other marine inhabitants. Like falling dominoes, one problem can follow another. And all this because of one bridge. In 2007, the Spanish Ministry of Environmental Protection introduced speed limits for all ships sailing through the strait in order to not disrupt the delicate balance of nature. At the beginning of the 20th century, a French engineer proposed a project of a bridge, but it was rejected because it was too complicated and costly. People also tried to develop a 23-mile-long tunnel, but this project also faced financial and technical difficulties. People are still dreaming of a bridge over the Strait of Gibraltar. Perhaps, in the future, when we develop cooler technologies, we'll be able to build this thing. Oh, by the way, there hasn't always been water between these two regions. In the distant past, the two continents were connected. The entire Mediterranean Sea is the remains of the Tethys Sea that existed before the era of dinosaurs. Then the African and Indian plates collided with the Eurasian one, and the Tethys Sea completely disappeared. In its place, a land bridge was formed that separated the Mediterranean Sea from the ocean. Without access to water, the sea dried up about 6 million years ago. But then, when the bridge came down, the water began to fill the dried-up pool. For tens of thousands of years, the narrow plate sank lower and lower, and the Mediterranean Sea eventually got its current water levels. Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritius. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Saul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species develop differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Saul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Most rivers in the world flow into the sea, but the Okavango in Africa takes its massive waters right into the Kalahari Desert. And it looks like this river manages to do the impossible and defies gravity. The Okavango starts in the highlands of Angola, runs for 1,000 miles like any other normal river, and then drops into the largest inland delta on Earth, known as the Okavango Swamp. The delta has land slopes dropping at nearly 150 feet, which is about half as tall as the Statue of Liberty. The area where the Okavango Delta is now used to be part of a lake that dried up around 2,000 years ago. It takes the Okavango water several months to complete its journey, and the landscape there is never the same. The first European to have found the delta was the Scottish explorer David Livingstone. Yeah, the Dr. Livingstone, I presume, guy? That's him. When he first saw it, he was shocked as he noticed that the water seemed to be flowing backward and even uphill. He saw two strong watercourses connecting the Okavango to the wetland systems to the east. Decades later, other explorers saw them completely dry. Several years later, the watercourses were full again, and they kept emptying and filling up, sometimes changing direction. Scientists managed to explain this mystery when they found a hidden network of faults, part of the Great Rift Valley, under the sand. When major earthquakes happen, like the one in Indonesia in 2004, the Earth sets off a chain reaction. Tiny cracks underground shift just enough to send a trickle of water down the river, and a flood begins, raising the water levels. Plus, in May and June, when winter begins in the southern hemisphere, floods bring more fresh water and life to the swamp. Islands get submerged completely during the peak floods and then resurface again at the end of the wet season. Wildlife just loves all the water in the delta, and you can often see migratory elephants bathing among pink lily pads and silverfish, bream, barbels, and other fish. There are lions, cheetahs, buffalo, wildebeests, hippopotamuses, hippopotami, zebras, wild dogs, crocodiles, and other species of animals. Storks, ibis, herons, cranes, and geese like to fly by, along with 450 species of birds. Although the Okavango has plenty of water that is priceless in the desert, people hardly settle along its banks. One big problem here is the tsetse fly. But if you're feeling adventurous, you can come here for a water safari. Scientists from Imperial College in London stumbled upon a totally unexpected river under the Antarctic ice sheet. It slurps up water from an area as big as Germany and France combined. Scientists used to think the lakes under the Antarctic ice were just chilling by themselves. But now it turns out they're part of an interconnected river network. Water under the ice can form in two ways, either from melted snow seeping down or from the Earth's natural heat and the ice grinding over the ground. The Antarctic gets a lot of surface melting during the summer, but Antarctica is usually too chilly for that. This newly found river is proof that there's plenty of water down there just from the ice melting from below. This river could make Antarctica lose its icy cover way faster. If things heat up enough to melt the surface, that water could rush down and mess with the base of the ice sheet, turning Antarctica into a melting mess like Greenland. If the ice starts moving faster than the water can handle, it's going to create more friction, making even more water and speeding up the melting process. The researchers are on a mission to dig deeper into how this river system works and see if it's causing trouble in other parts of the icy continent. Understanding what's going on down there could give us a heads up on how a changing Antarctica might shake up the whole planet. The Roe River in Montana flows for just a bit over 200 feet between Giant Springs and the Missouri River. It was mentioned in the Guinness Book of World Records as the shortest river in the world, but they had to remove this category altogether because there was some heated debate over this title. Residents of Oregon claim that their D River was the absolute champion, as it all depends on when you measure them. There could even be shorter rivers in Norway or Indonesia, depending on what you see as a river. The official definition says it's something that has constant flowing water in the form of a current and is fed by upland sources or another river, lake, or watershed. Creeks and brooks flow together to form streams. Streams become rivers, and rivers take the water from higher to lower lands, ending in the ocean. There are 12 stream orders, and the first two levels don't have other streams feeding them. So, Roe and its other short buddies technically deserve the title of rivers. I'm glad we cleared that up. Rio Negro in South America is the largest blackwater river in the world and the largest left tributary of the Amazon jungle. Its waters look more like strong tea and seem pitch black only from the distance. They get that dark color from humic acid. When plants containing phenol break down only halfway, they leave behind this tea-like hue. Some people believe that blackwater rivers can't be productive, but Rio Negro helps big fishing industries and has spots where turtles come to lay their eggs. Back in the 17th century, explorers didn't find tons of indigenous folks along the river. But it probably didn't have to do with its productivity, more with diseases and conflicts. There are around 700 different fish species documented in Rio Negro's basin, including at least 100 you won't find anywhere else. A bunch of those fish end up in aquariums, like the super popular cardinal tetra. There is a canal connecting Rio Negro and the Orinoco, which is another major river in South America. Many aquatic species try to move between the rivers, but only the toughest can handle the mix of blackwater and clearwater sections in that canal. There's a unique creek in Wyoming that drains both into the Pacific and the Atlantic Oceans. It begins high up in the Teton Range and later splits into two branches. The Pacific Creek joins the larger Snake River, which merges with the Columbia River and finally reaches the Pacific Ocean. The Atlantic Creek heads east and flows into the Yellowstone, Missouri, and Mississippi rivers and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers who were looking for the Northwest Passage between the two oceans never knew they could have used the creek. They would just need really tiny boats. Some scientists believe that cutthroat trout knew about this route long before people. They managed to migrate from the Snake River to the Yellowstone River, most likely using the two-ocean creek. Now, every summer, the Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just perfect for the riverbed to turn bright red, yellow, green, blue, and black. You gotta thank certain aquatic plants growing in the river, a special type of seaweed for all this beauty. During the wet season, the river moves fast, and the sun cannot get to these plants. When the dry season hits, there isn't enough water to feed them. So, the time in between the seasons has the perfect conditions for this colorful show. No other place in the world has anything similar. So, at some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours for visitors. Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangaea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA is keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700. But still, it's a reminder that Earth is always in the cosmic firing line.
Okay, let's play a little guessing game, shall we? Can you name the 6th largest river on Earth in terms of volume? That's the amount of water that flows through a waterway. The first couple of rivers are easy to list. Number 1, of course, is the Amazon River in South America. Then we have the Congo in Africa, and the Ganges in India. Feel free to name all the rivers on the planet. You won't get any closer to the answer. Why? Because this river is not on the surface, but underneath the waves of the Black Sea. In 2010, a team of scientists discovered this river while studying the Bosphorus Strait in Turkey. Sonar scanning revealed a channel at the bottom of the Black Sea. The channel had water flowing through it. It turned out that at places, it's 115 feet deep. That's 3 times as tall as your average telephone pole. This flow of water acts like a real river. It has rapids and waterfalls, and its volume is 350 times greater than that of the River Thames in London. Talk about a strong undercurrent. If it was a surface river, it would really be in the top 10. Bad news for the Madeira River in Bolivia and Brazil, the present number 6. But how did this underwater river form? The answer lies in the amazing features of the Black Sea. It gets its water from 2 main sources. The first are the rivers that flow into it, like the Danube, Dnieper, and Don. Lot of D's there. But more importantly, they are all freshwater waterways. On the other side, quite literally, there is the Mediterranean, and it's salty, like a lot. When this salt water gets inside the Black Sea, it goes straight to the bottom. You see, fresh water is lighter than salt water. This creates stratification. It's a fancy term that simply means that the 2 types of water don't mix together. Salt water has a higher density, so it drops right down to the bottom. If you want to see how that works, you can do an experiment at home. Pour mineral water into 1 cup and salt water into another. Table salt will do. Then put a grape in each cup. You'll see how it immediately sinks to the bottom of the cup filled with fresh water. The grape will stay afloat in the cup filled with salt water. The same thing is happening inside the Black Sea. But there is another side to this phenomenon. The upper layer of water is rich in oxygen. This means it can support life. The bottom layer, however, is anoxic. Yep, you guessed it. This means there is no oxygen at the bottom. But this isn't a bad thing. Because of this trait of the Black Sea, shipwrecks are able to survive for centuries. Oxygen decomposes wood. And from what material did the ancient people make their ships? That's correct, timber. Recently, in 2018, scientists discovered the oldest Greek shipwreck on Earth. The merchant ship lies more than a mile deep at the bottom of the sea. Experts estimate that the vessel is 2,400 years old. The wreck was valuable for historians to study all the elements of ancient ship construction. From the mast to the rowing benches, it's all intact. The wreck lies some 50 miles off the coast of Bulgaria, but no one has seen it in person. Explorers sent a deep-sea ROV, or remotely operated vehicle, to film the wreckage. It was impossible for a diver to go down. But the Black Sea doesn't look that huge on a map. Could it be that deep? Oh yes, it's way deeper than people think. You could stack 6 Empire State Buildings at the deepest point of the Black Sea, around 7,257 feet. This inland sea isn't the only place on Earth where researchers have discovered shipwrecks and underwater rivers. One of the largest channels running along the ocean floor lies off the coast of South America. It runs from the mouth of the mighty Amazon and into the Atlantic Ocean. Studying underwater rivers isn't an easy task. The depth and the strong currents make it impossible to send in divers. Even the equipment for underwater research has to be sturdy. Otherwise, the current will just wash it away. That's why the underwater river in the Black Sea was ideal for scientists to explore. Earth's oceans and seas are powerful. But, lucky for us, there are places where divers can admire underwater rivers. Ever heard of a cenote? Sounds Spanish. Well, that's because it is. Cenotes are underground caves. They form after the limestone above collapses, revealing the groundwater under them. The term cenote is associated with the Yucatan Peninsula in Mexico. Ancient Maya used them as water sources. In the Mayan language, the word cenote meant sacred well. Researchers estimate there are some 10,000 cenotes spread across the Yucatan Peninsula. You can also find them in other places, such as Cuba and Australia. Beauty is in the eye of the beholder, but unofficially, the most beautiful cenote is located just south of the town of Tulum in Mexico. The name reflects the cave's divine beauty, Cenote Angelita. But people don't visit this cenote to go swimming. Its bottom is much more interesting. A scuba tank is all you need to finally admire an underwater river firsthand. The waters are dark and foggy, so divers use powerful flashlights. After a 100-foot dive, a marvelous sight appears. An underwater river with trees along its banks. Some of them even have green leaves, just like any other water flow on dry land. But it's not really a river. Here comes the fascinating part. Remember how saltwater and freshwater don't mix? Well, the river the divers see is actually a thick layer of fog between the two types of water. 3 feet of hydrogen sulfates to be exact. This is the compound that water processing plants use to remove chlorine from drinking water. The substance is so heavy that the fog it produces moves independently from the surrounding water, and it creates an illusion that a river is flowing underwater. But there are other real rivers that play tricks on you. Take, for example, the Mystery River in Indiana. It's the longest underground river in the United States. Explorers discovered the river and its cave system, Blue Spring Caverns, in the 19th century. Nearly 3 miles of the river are navigable. Isn't that impressive? You can book a boat tour on a river that you can't even see. But the most mysterious river on the planet is the Saraswati River in India. The coolest part about it is that it doesn't exist. It was an alleged river only mentioned in ancient literature. For centuries, people thought that it was just a myth. Then satellite images showed that it might be real. Ancient texts spoke of a major confluence of three mighty rivers, the Ganges, Yamuna, and Saraswati. The first two are visible today, but where's the third one? That's what scientists decided to find out. Images from an American satellite showed the presence of underground water in the area. Until then, researchers thought that these were paleo channels. This simply means that water flowed through them a long time ago. But, to their surprise, it appeared that there was still water inside these channels. Scientists estimated that the Saraswati River flowed above the ground some 5,000 years ago. But it didn't dry up completely. It just went underground, some 200 feet below the ground. Local experts believe that the river still slowly flows into the sea. The Saraswati River got hidden under the desert sand. This was a natural process, but many rivers have been forced underground because of human activity. In London, England, several dozen small and medium-sized rivers now flow under the ground. Maps from the 19th century still show them as rivers, but today they only exist in the names of the streets that were built above them, such as Fleet Street. The same thing happened in New York, but this doesn't mean that these streams have disappeared for good. When engineers want to rebuild or modify a building, they still consult city maps from centuries ago. No one wants a long-lost brook to flood their basement.
Imagine there is a huge crevice right under your house. What would you do? Probably pick up your belongings and evacuate the structure. This is what happened to one Kenyan back in 2018. A massive crevice formed almost overnight under his home. The man escaped to safety, but the event revealed a deeper issue, much deeper than most people thought. The crevice appeared after a month of heavy rainfall. This part of the country, west of the Kenyan capital of Nairobi, sits in a seismically active region. The massive hole in the ground was covered with ash from a nearby dormant volcano. The crevice in the ground ran for miles, and it was 65 feet wide in some places. It was as deep as the Hollywood sign is tall. The gaping hole damaged a vital local road. People soon dubbed it the Grand Canyon. But this is no laughing matter. The same thing happened in 2023. Kenya's highway authority had to close the busy road for repairs once again. Preliminary reports showed that heavy rains were the likeliest cause. The rupture itself is part of the Great Rift Valley. It extends from Jordan in the north to Mozambique in eastern Africa. Its total length is nearly 1.5 times the distance from New York to Los Angeles. Rift valleys are located all over the planet. They're lowland places where tectonic plates move apart or rift. These are huge slabs of rock in Earth's outermost layer. They rest on molten rock underneath, which makes them unstable. Tectonic plates are constantly on the move. They can bump into each other, or one plate can go under another. This can occur both on land and at the bottom of the ocean. Continental rifts are less frequent than the ones we find underwater. The East African Rift is one of 4 major ones. The nearby Arabian Plate has been on the move for the last 30 million years. When it separated from the African mainland, it created the Red Sea and the Gulf of Aden. When you look at the physical map of Africa, it looks like one contiguous landmass. But when you dig deeper, quite literally, you realize it rests on 2 tectonic plates. The Nubian one carries most of the continent. The smaller Somali plate holds the Horn of Africa. The crevice in Kenya appeared in the rift valley between these 2 plates. That's because they're moving away from each other. The rift is growing larger, which means that one day the African continent will split into 2. The rifting process is a slow one. The present rate is just 1/4 of an inch every year. Scientists estimate that the split will occur in 5 to 10 million years. Some experts place this event 50 million years into the future. The end result will be two African subcontinents. They will be separated by a body of water that will become our planet's sixth ocean. This also means that 5 now landlocked countries will get access to the sea. When they get a coastline, the countries could build harbors to trade with the rest of the world. 3 other countries, including Kenya, would find themselves on 2 continents. The future split of Africa into 2 parts might sound dramatic at first, but it wouldn't be unnatural. This is the first time, after hundreds of millions of years, that the shape of Earth would change so much. The last time this happened was during the Jurassic period. If you're now thinking of Steven Spielberg's 1993 blockbuster movie, you're right. The world of dinosaurs had a different shape than the one we're familiar with today. There was a supercontinent called Gondwana. It included today's South America, Antarctica, India, Africa, Arabia, Madagascar, and Australia. Then, around 180 million years ago, things started to change. Earth was starting to take its familiar shape. The Indian subcontinent collided with the Asian mainland. The event gave rise to the Himalayan mountain range. These are the highest mountains in the world, with 30 peaks over 24,000 feet in altitude. This process is far from over. The Himalayas are still growing in height. On the other side of Gondwana, Africa and South America first separated together. But they weren't meant to last long. 40 million years later, South America started drifting away from Africa. This created the South Atlantic Ocean. The evidence of this ancient continental drift is obvious to this day. If you look at the map of South America, you'll notice a bulge in its eastern part. That's the modern country of Brazil. On the other side of the Atlantic, Africa has a huge inland curve on its western side. The two act as pieces of a giant jigsaw puzzle. They roughly fit into one another. European scientists noticed this as early as the 17th century. Further research confirmed the theory that South America and Africa once belonged to the same landmass. This is only one part of the story. At the beginning of the 20th century, a German scientist came up with the theory of continental drift. He believed that all of Earth's continents were once part of a supercontinent called Pangaea. The name comes from Greek, and it means all of the Earth. Makes sense, doesn't it? It was surrounded by the oceanic ancestor of the Pacific Ocean. Some 200 million years ago, this gigantic landmass was home to many animal and plant species. Thanks to them, scientists could piece together what our planet used to look like. For example, Mesosaurus was a giant freshwater reptile that existed during the Cretaceous period. Paleontologists found its fossils in only 2 places, Africa and South America. The animal lived in fresh water, so there was no way it could have swam in the Atlantic Ocean. This pointed to the fact that it lived in a single habitat, rich in rivers and lakes. This would have been possible in only one scenario. The 2 continents that are now miles apart were once a single piece of land. Pangaea wasn't the only supercontinent in Earth's history. Continents came together and drifted apart several times throughout our planet's past. Researchers know of at least 3 times this happened. Pannonia formed 600 million years ago. Rodinia was an even older supercontinent. It existed a billion years ago. The driving force behind all these changes was tectonic activity. Plates deep beneath our feet have the ability to create new land and oceans. This is what's happening in East Africa right now. This activity is most evident at the bottom of the sea. Molten rock rises from deep within the earth to create new seafloor. The process is called seafloor spreading. It happens along underwater mountains called ridges. One example is the Mid-Atlantic Ridge. I think you can fairly accurately guess its location. Over time, the seafloor grows wider here. This has an effect on the continents on both sides of the ridge. Seafloor spreading causes continents to move away from each other. Right now, North America is moving away from Europe at a rate of 1 inch per year. This doesn't seem like much, but give it 50 million years and the Americas are gonna bump into the western part of Asia. The two landmasses will form a new supercontinent. Geologists from Yale University have a name for this land: Amasia. Talk about rushing before the ore. They ran a series of computer simulations to see what Earth would look like millions of years from now. The new continent is likely going to form somewhere around the North Pole. But don't go shopping for winter clothes just yet. The time frame for this event might extend to 200 million years into the future.
There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the time. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from